Hello students, this is going to be the last video in the video series on applications of derivatives. And the reason I decided to do an additional question is this one we actually do have to consider the endpoints, which we haven't had to do in the last two examples. Okay, let's get started. A hostel manager agrees to accommodate a party of students for $70 per student for a party of 50 students. He also agrees to reduce the tariff by $1 per student for each student in excess of 50 students up to the capacity of his hostel, which is 75 people. So what is the size of the party which will maximize the revenue for the hostel owner? Okay, let's get started on this one. To start with, hopefully it's fairly obvious that this is not a question that really a diagram is going to be useful for. In fact, I couldn't even think how to draw a diagram for this. So diagrams are normally useful when you're trying to find an area or a volume or something like that. So in this case, no diagram possible. Okay, the next step then is to find an equation for this particular problem. And this is actually the trickiest part of the whole question. Once you can actually get an equation for this, the rest of it's relatively straightforward. So there's a couple of ways you can do this. In fact, what you might want to do is try it on your own to start with. See if you can find a formula involving the number of students and the revenue, and then check it against my answer. Now it turns out there's two different ways you can do this. I've actually done it this way. I've let n be the number of additional students, and then I found a formula for revenue in terms of n. But the textbook, for example, that I got this question from, it actually says let n equal the total number of students. So there's two ways you can do it. In the end, you get the same answer either way. So I'll show you how I figured this one out. Okay, so what I did is I said I'm not too sure how to get the equation, so I'm going to go ahead and make up a table and see if that's going to help me find an equation for the revenue. So n is the number of additional students, and r is the revenue. So I said, well, if I don't have any additional students, that means I've got 50 students paying $70 each, so that's the expression for the total revenue. If I have one additional student, that means I have 51 students, each paying $69 each. If I have two additional students, I have 52 students paying $68 each, and so on. So from that, I was able to come up with the general formula for that. If I have n additional students, then I have 50 plus n students in total, and each of those is paying 70 minus n dollars. So have a think about that. That should make sense if you have thought about it. And that means I now have the formula for revenue, the total revenue just there. Okie dokie, the next stage, of course, is to, well, let's go ahead and expand this because it's easier to find the derivative in expanded form than in factorized form. So that's the expanded form of that. And the next step, of course, is now to find the derivative of that. That's pretty straightforward. Derivative of 3,500 is 0. Derivative of 20n is just 20. Derivative of n squared is 2n. Set that equal to 0 to get the turning point or the stationary point. And therefore, we end up with 10 additional students. So that's where we're up to so far. Now, we don't know yet whether that's a max or a min. And the easiest way to find that out, finding the nature of the turning point, or the stationary point, I should say, is to find the second derivative. Well, the second derivative of that is just -2. And because that's negative, that means this value here is going to give us a maximum revenue, not a minimum revenue. And of course, that's the number for additional students. So therefore, the total number of students would be 60. Okay, now one last step. We've got to then check the endpoints, just in case one of those gives a larger amount of revenue than the 60 students does. So let's check the endpoints. So first off, the domain, the minimum number of students is 50. The maximum number of students is 75. So we've got to work out the revenue for 50 students, 60 students, and 75 students and see which is the absolute maximum. So for 50 students, it's 50 times 70, which is $3,500. For 60 students, the 60 students each pays $10 less than that because there's 10 additional students. So the total revenue for 60 students is $3,600. And similarly for 75 students, each of the 75 students only pays $45 each, which means the total revenue is $3,375. So therefore, the maximum revenue, in fact, is when we have 60 students. Just in passing, before we finish this video, this wasn't a very good idea on the part of the hotel manager. Let's say that 75 students actually turned up. It turns out he's going to end up with less money having to feed 75 students than if he had to feed 50 students. He's going to have less income from that. So he really should have done a little calculus question before he agreed to that, I think, anyhow. Okie doke. Well, that's the end of the video series. There are lots and lots and lots of questions, optimization questions, both in textbooks and online. Some of them are quite challenging, so my suggestion is go ahead, try a few, start with some simpler ones, and then work your way up to some of the really challenging ones. And thank you very much for watching all the videos. Goodbye.